All right, so the major part of this exercise is for us to understand the quadratic inequalities. As we had the linear inequalities, I told you guys the basics that you need when you're solving the linear inequalities as you had them from your grade 10. That was just a continuation. But in this case, we are referring to a quadratic. What is it first that we are supposed to consider? Or let me just use somewhere here on top here. So the first thing is, what are we supposed to consider the moment we are having this part of a quadratic? Take note, guys. Saying this is a quadratic. So we're referring to the quadratic inequalities. So let's start by this quadratic. We had this part of the quadratic working with the quadratic expressions, factorization of the quadratic expressions. We had this part of quadratic when we are working with quadratic equations. Remember, ax squared plus bx plus c is equal to 0. When we're working with the quadratic equations, the highest exponent there is a 2. But this time, they are not supposed to be an equation. It is not supposed to be equal to 0, no. It is either this is supposed to be greater than a 0, it can be less than a 0, it can be greater than or equal to a 0, it can be less than or equal to a 0. Your quadratic expression now is compared to a certain value. So that's not an equation. An equation you're obtaining exactly to say x is equal to 3 or x is equal to 4. These are the solutions of an equation. You are having exact solution. But inequalities are supposed to have either x is less than 3 or you're giving us x is greater than, depending with the final solution. So what I want you to understand are these solutions are for the what? Inequalities. You understand me very soon. This is for the inequalities. Whereas if I'm writing x is equal to 3 or x is equal to 4 like this, here I'm solving what? An equation. An equation. So I want you to understand this because in these quadratic inequalities, there is a part where we are going to work with an equation. So you must know that. Where you are finding x is equal to 3 or x is equal to 4. These are the solutions which we refer to as the critical values. The critical values, which I'm just going to write in short as we are moving on like this. The critical values. Those are the solutions when solving an equation. The exact solution of an inequality are the one that we are comparing now according to the method that you are going to have at the end in comparing the solutions at the end. Are you going to use the number line? Are you going to use the graphical method? Are you going to use the idea of the table method? So many ways. It's a comparison that you're supposed to have the final solution. All right, so let us quickly go through these questions. I'm going to explain, try by all means, explain with questions. So this is mathematics, guys, you know. The best way to explain mathematics is by calculating, because it's not English, guys, where I have to be so grammatic and this thing. No. Okay, anyways, this is what we have. On the first question, we're given, solve the following inequalities. X is less than or equal to 16. All right. This is our first question that we're going to work with. X is less than, x squared, is less than or equal to 16. X squared is less than or equal to 16. So we are going to have, I think this class is going to take a lot of time because there are so many methods that we need. And at the end of the day, it is you who is supposed to choose which one do you prefer at the end. So this is it, guys. The first thing is to work out or to calculate the values of X, which are called the critical values. Work out the critical values. All right. That is the first thing that you need. So to work out the critical values, guys, it's just like you are solving an equation, not an inequality, but an equation. Take note there. Take note there. It's like you're solving an equation. So this is it. As we understand, we could have determined this equation by introducing square root. Then we say x is equal to plus or minus 4, which is fine. Because when you take it as an equation, it means x squared is equal to what? 16. Then you square root. So x is equal to what? Plus or minus 4. There are two values there. But in a normal calculation, guys, we can see there's a difference of two squares which can be formed. Was this a perfect square? It's also a perfect square. So instead of us introducing the square root, we can take the 16 to the other side of the inequality. That is going to give us x squared minus 16 is less than the side here that we are seeing is a 0. Remember the illustration that I was having of the format having these inequalities in the form of ax squared plus bx plus c. It is either it is greater than, it is less than, it is greater than or equal to 0, less than or equal. Any of this, you're supposed to be comparing with a 0 there. Just like what you have on your quadratic equation. So that is going to help you on your final solutions. So the shortcuts, yes, they play a role. But you are supposed also to understand them. So without having those shortcuts, this is what you have, guys. All right, let us have a difference of two squares. Do you understand the square root of x squared is x minus the square root of 16, which is 4. Remember, one bracket is going to subtract. Another bracket is going to add. That's less than or equal to what? To 0. You awake, this is an inequality. So on the critical values, the ones that we need here, they are not part of the inequality. This is solving of an equation. So we are now solving this as an equation. So our critical values at the end, we are now saying x must be equal to what? The minus 4. Remember, when solving an equation, it will be x minus 4 is equal to 0, or x plus 4 is equal to 0 from these two brackets. So the minus 4 to the other side will give us a positive 4. So x is equal to positive 4, or x is equal to the 4 to the other side is going to give us what? A negative 4. These are the critical values, not exactly what we need as part of the solutions. After determining or having the critical values, that's where now you're supposed to determine or to work out the solutions. Determine the exact solutions there. Exact what? Solutions. According to the method now that you understand. So the methods, they differ on determining or having the critical, I mean on determining these exact solutions. Take note on that part. All right. So I'm going to start with the graphical method. Move on to another one. So let us just have the methods here using the graphical method. So I'm just going to explain a few examples. Then I want you to try those questions where there are challenges. We talk about that. We have another class where we're going to split again the class. All right? Because we cannot answer all those questions there. So the graphical method is going to be like this, guys. Using the graphical method, you must understand when the ax squared plus bx here is compared to the 0. We must understand that. Why are we supposed to understand this part of ax squared plus bx being greater than or less than whatever that you're given there? Remember our functions. When you're given a function from your grade 10 mathematics or the functions, if we are given the a that we have here, on a condition that a is greater than 0, we are talking of the positive values, we are going to have what? A smiley shape like this one. This is what we are going to have. The shape is important. If this a is less than 0, we're talking about the a of this part of our quadratic, meaning to say we are referring to the negative values. Our shape is going to be in another way. So this is what we are going to have. So meaning it is important for you to understand the graphical concept, the shape that you're going to have. So remember, these are the critical values, which are the solutions to the function when you are to present this. If we are to consider the part of ax squared, this part that I'm explaining here, of ax squared plus bx compared to 0, this is exactly what we have here when we are on this part. X squared minus 16 is less than or equal to 0. This is what we are given. This is what we are given. So we are going to have the comparison compared from this one. X squared minus 16 is less than or equal to 0. That is where our comparison is going to be made. So first, on the function, what are we having on the function? The a, the coefficient of x squared, there is 1. We are talking about a number which is greater than 0, a positive. So from our graphical interpretation that we understand, we understand that it was supposed to be a function like this, okay, where this is your y-axis. Do not worry about this, but you can just present if you want. That's the 0 there. X is minus 4. Another x is a plus 4. So you're going to have a minus 4, and this is going to be a plus 4 like this. All right. Like I said, a is greater than 0, so you're going to have what? Smiley shape like this one. All right. So they do not worry about sketching exactly the function. We just need to understand the shape, how it is presented, and the values that we are having here on the end. So this is where we are. So the graphical method now here is telling us a lot of things. It gives us solutions as we present it on the graph. As we present any function on the graph, we can tell the function, the solutions, how are they going to be. So in this case, let me just refer to the x-axis so that we do not waste much of our time. So it will be like this. This is your x-axis, remember? So if we are given a function like this, let's say this is the function that we have. It is crossing the x-axis at this point A and at the point B. Point A and point B. When the function is greater than, when you are referring to the function now, you are talking of the ax squared. Ax squared plus bx plus c. When it is a condition that it is greater than 0, or maybe they are saying greater than or equal to 0. The equal to there is just something that you put on your final answer, but it is the same position where we are going to have this solution. We are referring to a condition or a solution where our function is above the x-axis, that is being greater than 0. Remember, in the x-axis, we say y is equal to what? Y is equal to 0. We are comparing to 0. So greater than, that is values above. You're talking about values above 1, 2, 3, 4, above x-axis. These are the values that you're talking about on top of the x-axis. So if there are values on top or above the x-axis, this one, we are going to have our solutions this side. This is where we're going to have our solutions there. So I want you to get rid, and this is going to be the same on each and every question that you have. And on this side, where we are shaded here, these values compared to A, we're talking about, let's say this is a 1 here. That means we're going to have a 0, -1, -2, -3, -4. So just comparing these values, we can see that they will be less than the number that is here. Let's just take a closer look to say here, let's say the number that is at this point, guys, you know the number at this point. Let's say that number there at that point is a 7. Let's say the number there is a 7. These numbers they are going down. 6, 5, 4, 3, 2, 1, and so on. Compare these numbers to 7. What are they? They're less than 7. So meaning to say all these values that you are going to have on this side of A as part of your solution, they're going to be less than A. So X will be less than A, depending with what you're given. If it is a condition where it is greater than, like that, your solution is just going to be like this with a less than sign. But if there is a greater than or equal to, if you see this greater than or equal to this one, then you have to put it also on your answer. If it was greater than or equal, your solution also must have this line of an equal to represent the equal to. So that one, you take it from the inequality question. If this part is there, your solutions also must have it. If it is not there on the question, therefore do not put it on the solution also. Do not put it. So there, it depends. Please take note, all right? So I'm just going to put it like this so that we know that it can be an equal to, can be there also. So this will be your first solution. Another solution will be the values from B. Remember, we've got this side and we also have this side. On this side of our graph, these values, let's say this is a 3. How do you count values going this side to the right side? They're increasing 4, 5, 6, 7, 8, 9, 10. Those values, they are bigger than the value that is at this point. Those values will be bigger than that. Remember, those are X values. So the X values talking about, that will be having, they will be increased. They will be more than this value that is at this point B. So meaning to say another part X representing those values that we are talking about that are increasing, going to the right side. Those are the X values. They will be bigger than what? Bigger than B, greater than B. Let's say this is a 5. So we are saying our X is greater than 5. We're saying these values, they are more than 5. They are bigger than 5. That is what it means. So that is how you take your solutions there. If there was an equal to on your answer, like I was saying, to say there's an equal to on your answer, your solution also must have what? An equal to. The inequality sign of the question that you're given on the question is supposed to affect your answers as well. All right? Your inequality sign. So take note. This is a condition. Let's just name it number 1. So we say this is a condition when ax squared plus bx plus c is greater than 0, or it can be greater than or equal to. So this one, just putting aside to say it can be greater than or equal to 0, then you put it like this, okay? When it is greater than 0, greater than or equal to a 0, it's one region that you're going to have your solution, this side and this side. But they can give us a condition where this function that you're given, this time it's less than a 0, meaning to say in place of being less than a 0 like this, they can give us as what? As less than or equal to 0. It's one and the same. You just need to know what to do on your final answers. But the region represented there is one region that we're talking about. For a less than 0, for a less than or equal to 0, it's one region. So which region are we talking about when our function is less than? Remember I said y is equal to 0 is what? is your reference, which is the x-axis. So when you say it is less than 0, you're talking about below the x-axis, below the x-axis. So where do we find the solutions that are presented below the x-axis? These are the solutions here. Below the x-axis, this is what you're going to have here. Below the x-axis. So your solutions will be taken in between A and B. In between the numbers that will be given. If this is 3, if this is 5, they'll be taken in between 3 and 5. So how do we write these solutions? X will be greater than A, but the same X that we are talking about to say it is greater than A, the same X compared to B, it is less than B. The same X is less than B. So this is where I was saying, if your question has an equal, this one, an equal to, if it is there on your question, on your answer, it must be there also. You must have it on your answer. You must have it. But if the question is not having that, if it's just less than 0 like this, your answers, they are not supposed to carry that equal. All right. So I'm just going to put this also aside to show that it can be what? Equal to, depending on the question. So these two conditions are the one of this nature, guys. As long as our function is like this, we are going to have our answers this way. This is this one. So it's about the question now to say, is it greater than 0 or is it less than 0? That is the condition there. For this type of a function, meaning to say we are referring to a function where A is greater than what? 0, which is a positive. This one, which gives us a smiley shape like this one. Let's say, let's just have another one. Okay. So this is, let's just say, all right. So like I said, this one is on a condition where A is greater than what? Where A is greater than 0. So let's have the last one where our A is less than 0. We saw that it's a negative and it's going to have a set shape like that. All right. So let's see how it is going to be like in terms of your solutions, actually, but it's just going to help you to even answer any question that you are given in any way, any question. So this time our function is going to be like this. This is what we are going to have. Our function is going to be like, it's going to be presented this way. That is how our function is going to be like. Remember, these are the solution, the critical values at point A and at point B. These are your critical values. So the first part that we had is that it can be a condition where ax squared plus bx function that we are given is greater than 0, or the function that we are given is greater than or equal to 0. Let's say this is what you are comparing to. All right, you have drawn this. This is what you have drawn. It is like this. Remember when it was like this, when it was giving us a smiley shape like this one, we said our solutions, they are above the x-axis, but they're saying it's greater than 0. So the solutions are taken above what? The x-axis. And we saw that if it is above the x-axis of a function now, we are still on above because they say greater than, or the function compared is greater than or equal to 0. We are still above. We are still on top of the x-axis. But this time, can we say these are the solution, this side and this side? No. On top of the x-axis, the solutions, when it is like this, you take where it is covered in, just like what we saw here, the covered part. We have a curve. Then when it is a curve like this, you take what is, this is where our solutions were going to be above the x-axis, greater than or equal to the whole function. So meaning to say, in this case, our solution was going to be what? X. Remember, how did I say when it is in between like that? X will be greater than A, but less than B. So it all depends now with the question. Was it, on the question, was it greater than or equal to 0? If there was a greater than or equal to 0, therefore you have to put what? That greater than or equal to, then you have to put the equal to here, the equal to there also. So it depends with the question, but where are you going to have the solutions above the x-axis? This is above. In this is the region that you're going to use this one. Just like that. Then the second case, is when this function, the whole function of ax squared plus bx plus c, when it is less than what? When it is less than a 0. When it is less than a 0 like this, we are talking about what? Below the x-axis. Below the x-axis. So if it is below the x-axis, are we going to take solutions here in between? No. We saw that where it is open like that. We take this other side and other side. So this is the same situation that we have. Where are we going to take our solutions? This side. So these are your solutions, and this other side, this will be your solutions. Meaning to say, from this side, what are we saying? What are we saying according to our solutions compared to A? X is less than A, this side. Or X is what? This side of B, comparing this pose. We saw that in terms of B, this side is we are going that X will be greater than what? Will be greater than B. So these will be your solutions now. So depending with the question, was it less than 0? Was it less than or equal to 0? If it is less than or equal to 0, therefore you must have an equal to also here, and equal to also on your answer. That is the only difference that you are having there. The sign that you are given affects your final answer as well. Sign that you are given affects your final answer as well. If it is just a less than, your answers will just have those less and greater than sign. But if there is an equal to, your answer must have the equal to also. You must indicate it on each sign that is on your final solution. So this is the graphical method. You must interpret it graphically like this. The function, you have your solutions, but those solutions that you are given now, the critical values must be compared graphically like this. So in our case, let's go to our case. This is where we are. This was your question. You understand now. You solved for the critical values and you got a 4 and a minus 4. These are the ones that you used to sketch the function. Remember the function that you are sketching here, x squared minus 16. How do you sketch this type of a function? This is the one that you're just having a sketch. A is greater than a 0, meaning to say we are going to have what? A smiley shape, like I said. Then you sketch. After sketching your function now, we are going back to the comparison here, the part that I indicated here. This is the part that is representing the ax squared plus bx plus c. What is it? It is less than or equal to 0. That is what we're given there, less than 0. So which part are we going to take on our graph when they're saying it is less than or equal to 0? So below the x-axis, this is the region where we are going to take our final answer. This is what we saw, guys, less than 0 on this type of a function here. This is what we have. When it is less than 0, this is how our solutions are going to be taken as below the x-axis. So x is greater than a, but less than what? Less than b. This is what you're going to have. So what is representing your a and your b? Your a is the minus 4. Your b is what? Is your 4. So therefore, you're saying x must be greater than minus 4, but less than a positive 4. Then compare with the question. What is it that was what was the sign on the question? There is an equal to. Take note. It's less than or equal to, meaning to say these solutions of ours, they're supposed to have also an equal to here. There must be an equal to here because it is there. Answers also, your answer also must have that. So if the question was not having the equal to here, we were not going to put it on our final answer. We're just going to put it just like this without that equal to. So that is where the equal to plays a role. Not to say when you see the equal to there, then it is affecting your question. No, it only affects the final answer. So you must also have it on your answers. So this is your graphical method. All right, we are going to use like I said, there are so many ways. But in this case, because of this, let me just explain the graphical method for now. Then we're going to find a part where we explain another method. Let me just do the example where we have the graphical method. We have other examples still on the same part. On B, this is x is 5. All right, x squared, that is the B part, where we are given x squared is greater than or equal to 25. So take note, there's an equal to on your question. So what did I say? First, we need the critical values. So let us take our 25 to the other side. Remember, one of the sides must be compared with what? With a 0 there. You must compare with a 0. So take the 25 to the other side. That's x squared minus 25 is greater than or equal to 0 like this. All right. So using the difference of two squares, definitely going to factorize, guys, squared, which is x. Then the square root of 25, that's 5. So you're going to have a minus 5 and a plus 5 on the other side. That is greater than or equal to what? Greater than or equal to 0. So you now determine your critical values to say, what are the critical values? The minus 5 to the other side gives us a minus, a 5 to the other side will give us what? A minus 5 at the end. So these are the values that we have as your critical values. Then we come to the sketching of the function. Now, remember, I'm still under the graphical method. So like I said, we are going to take the part which is compared, this part of ax squared, which is compared to 0. Where are we having that part? Where are we having? We'll see, this is the part here, x squared minus 25 here, x squared minus 25 and or equal to 0. The x squared minus 25, it is greater than, bigger than or equal to 0. Today it's a 1. Meaning to say we are talking about a. And I said if a is greater than 0, going to have what? A smile shape like that. So this is what we are going to have. So this time I'm just going to put it in shortcuts. So let me just have my y-axis so that we understand each other. So this is your x-axis. This is your y-axis. Remember, we need minus 5. So this is our 0 there. Let's say this is where we have minus 5. This is where we have positive 5. Remember, positive to the right side. All right. Then negative to the left side. The coefficient of x squared is a positive, meaning to say we're going to have a smiley shape like this. So our shape of the function is going to be like this. So that is what we're going to have as your function. Now we need where it is greater than or equal to 0, according to what we can see here. They're saying it's the function of ax. This is what is representing our ax squared plus bx plus c. It is greater than or equal to 0. Where look here on our function, if you still remember. Where is it that we have ax squared plus bx plus c being greater than 0? Above x-axis. So our solutions will be taken this way. There are two solutions differently. So this 25 is greater than or equal to 0. So be careful there. This will be written as what? X is, let's say this is a. It was going to be x is less than a. But are we having a? This is a number now that we have, which is minus 5. So x is less than minus 5, or x is greater than positive 5 on this side. Then we check our question. There is an equal to there. There is an equal to on our question. So our answer also must have that equal to. We must put an equal to here. We must put an equal to. So x is less than or equal to minus 5. Or x is greater than or equal to 5. This will be your solutions at the end, where x is representing every real number that you can have within that region. So this is how our inequalities work, graphical method. As long you have the critical values, guys, sketch that function, then from the sketch, determine your solutions with any, guys. There are only two shapes. These are the two shapes. Where a is greater than 0, you're going to have a smiley shape or a set shape like this one. Solutions will be like, unless if we have got a condition when we do not have solutions at all. This is what you're going to be expecting in your questions. Find out what is happening. All right, let's figure out. See, we've got x squared is less than 9. This can be C. So there we are given x squared is less than 9. So it is important that we do not have the equal to. It is not there. All right. So as usual, guys, the 9 to the other side, that was going to be x squared minus 9 is less than 0. Determining of the critical values, you have to find the x values by factorizing this. All right, let's factorize first. Difference of two squares, we're going to have x and x here, the square root of 9, which is 3. So we're going to have a minus 3. X will be equal to what? All right. So the first one, x is going to be negative 3. To the other side is going to be a positive 3. Or x is equal to a plus 3. To the other side is going to give us a negative 3. These are the critical values. X can be 3 or x can be minus 3. Then we sketch the function now that we are supposed to have at the end. From here, from where it is compared to the quadratic part being compared with what? With the 0, x squared minus 9. We're talking of x squared minus 9 then. The coefficient of x squared is 1 that is greater than 0. If it is greater than 0, I said you're going to have what? A smiley shape as we saw before. So this is, guys, I'm just going to have in short this time. Going to have our smiley shape like this. All right. So this is what you're going to have the solutions. Another one minus, another one positive. So comparing which one can be minus or positive. The left side is going to carry a negative. the right side will carry what? A positive. So let's say this is minus 3, this is positive 3. They are saying f of x, which is ax squared plus bx plus, is less than 0. On a function like this, where do we have solutions less than 0? Below the x-axis. And below the x-axis, we're talking about this region governed in between these two. So you said when it is like this, how do you write your solutions? X is greater than A, but less than B. So X is greater than this number, greater than minus 3, but less than what? But less than a 3. This is what we saw here. When it is below ax squared plus bx plus is less than 0, this is where we're going to have, that is how we're going to have our solution on this type of a function. All right, let's look for question. Is there an equal to on our question? No, we do not have an equal to here. We do not have it on our question. So it means we are not going to have an equal to on our solutions as well. Our solutions will remain like that. We only put that equal to here if it is on the question as well. If it is not on the question, it mustn't be presented on your solution as well. So be careful. Be careful there. That's the graphical method can give us the solutions at the end, but also as an individual, understand this part of your inequalities from the question to the solution. How do you present your solution from the question? If you are given a question, how do you present the solutions from that question? So like I said, as many questions as you can. Try by all means to work out as many questions as you are dealing with your quadratic inequalities. Sometimes we can have conditions where we have got negative values on part of x. When the x is having a negative, it means the presentation there is going to change depending with how you have presented your inequalities. Remember, you can also avoid having a negative. You can have that negative. You can avoid having that negative. It depends with your understanding, guys. It depends with your understanding. All right. When I'm talking about when we have a negative, okay, I'm going to take this question because there is a negative part that is there here on J. This one. I'm going to take this one. This part of J, this one. They're saying 1 minus 2x, x plus 3 is less than or equal to 0. 1 minus 2x, let's have it here. So that was 1 minus 2x into, is it 1 plus x? Oh, it's x plus 3, x plus 3 into x plus 3. This is our question there, into x plus 3, and they're saying it's less than or equal to 0. All right, so this is the part of J. Jenna, I'm going to explain this one. They're saying this is less than or equal to a 0. I want you to understand this question because it has something that is different from other questions. We can try other questions in terms of the factorization. I'm going to remember, guys, I talked about there's a class when I talked about factorization of quadratic expressions using the cheat method, this and that. So make sure you go through those videos so that you revise your quadratic equations. It is very, very important. Knowing your quadratic equations, factorization is important. So what is it that happened here? They already factorized this quadratic expression for us. It is already a factorized part. And being compared to a 0 like this. Remember, it is being compared to a 0. Meaning to say we are talking of the ax, it is there, the ax squared plus bx plus c, it's already here. Because we do not have any other number like there is a 6 or a 7, that's a 0 there. So the function is already compared with a 0. Like what we saw here, ax squared, is it greater than, is it less than? They've already compared that. It's already part of our quadratic. But the question is, okay, let's find the critical values first before you talk of the question. So the critical values you are going to determine from each bracket. Remember, I said this bracket must be equal to 0. So if 1 minus 2x is equal to 0, what are you going to have? 1, so you divide by 2. Is that so? Or x is, because already they factorized was, all right? You take the 3 to the other side, it gives you a negative. So x is equal to a negative 3. These are supposed to be the critical values which we are supposed to use on the graph. Remember, I talked about the graphical method here, which we are supposed to use now on the graph to say, is it going to be a graph like this? Or is it going to be like this? How are we going to tell? Because previously, guys, if we check, it was a normal thing that was normal to say we are having x squared minus 25 is greater than x squared is, remember, the one that is important. The equivalent of x squared is 1. So you see, okay, this one is going to be a smiley shape. The only difference, guys, is that here we were the ones who were factorizing x minus 5, x plus 5 is greater than or equal. This is where they are starting. This is like what we're given. So how can we tell about the x that we have, coefficient of x squared? You do so that we know, okay, it was x squared minus 25x. If we understand truly these part of your factorization, we'll see that when the x squared is given, this one, it was simply taken from this x times x, x times x. Where there's an x, we can tell to all brackets that we are given there so that you know, okay, this was exactly the quadratic expression that was being given before. Guys, remember, you're dealing with time. This is maybe for the basics, you can do that, but for exam, you don't have all that time. So how do I tell about the shape? I focus on the coefficient of what? I focus with the part of x, where x is. There's x here, there's also x here. This is the only part, x and x. That is where we can get x squared. So minus 2x. When it multiplies this x, what are you going to have? Minus 2x and x is going to give us what? Minus 2x squared. So we can see that the coefficient of x squared is a negative 2. Remember, ax squared, all right, I wrote it here. Ax squared plus bx plus c when you expand. So you can see that the coefficient of x squared, our a there is what? Is a negative. Our a is less than 0. It's a negative value. So if less than 0, we are going to have this. This is our condition of our question now. Plus x plus 5 in one bracket, x plus 2 in another bracket is greater than 0. Check to see if x and x are being affected together. If x and x are being multiplied together, where x and x are, where are they? If they are multiplied together, this x and this x is going to give you x squared. Which is what? Positive. Then you can tell, all right, if it is positive, I'm going to have what? A smiley shape. Don't expand everything. In this case of the two brackets of this nature, when they are already compared to 0, take note what I'm saying. When they are already compared to 0, don't expand the whole brackets. Just focus with x. All right. So we saw that our a is minus. So our shape is going to be like this. If it is a negative, we saw that it's going to be a set shape like this. So meaning to say, at the end, we were going to have our shape like this. So this is what we're going to have this time, where our solutions comparing minus 3.5 minus is on the left side. So this is going to give us a minus 3. Half will be on the right side. So it's a positive, that one. So that's a half there. So this working with this type. Remember, we saw this function is going to x squared plus bx plus is greater than 0. Our solutions on top will be in between. If it is less than, this will be your solution. This time you're working with this type of a function. So in our case, what are they saying? If x squared, this whole function, the whole of our function, what is it compared to the whole of this function? This one, it is less than or equal to 0. And on a function of this nature, when it is less than 0, we are talking about below the x-axis, this side and this side. When it is less than 0, guys, here. We saw it here. When our function is less than 0, this one, when it is less than 0, this is less than a, or x is greater than b. So this is what we're going to expect even on our question here. So according to these solutions, we can say our x compared to 3, to minus 3, these values minus 4, minus 5, minus 6, compared to minus 3, they are what? They're less than. So x will be less than -3, or x a half, these going to 1, 2, 3, 4, and so on. They are bigger than. That was the question. There was equal to them. On your question, there's an equal to. So meaning to say your answers also, they must have that equal to. They must have that equal to. Do not forget that. Your question affects your answer. Your given question affects your answer. If there is a greater than, also your answer must have that. So this is it, guys. As long you are dealing with these quadratic inequality, there's nothing, guys. Know how to factorize, determining the on its own because of the coefficient of what? Of x shape. That one is being from the coefficient of x squared, the function that you're given. So if there are two brackets, just focus with x, right? And see if we're going to have a which is positive or a which is what? Which is a negative from this of the two ways. If there are two brackets compared to 0, all right, you must just apply that concept. But if it is not equal, like what we have on K here, expand everything, take the -12 to the other side, form a normal quadratic inequality. Then you start again to factorize when it is compared to 0. So you must be very careful there. Must be very careful on your simplification. So I want you to try as many questions as you can. As we can see on I there is this part where you need to factorize. All right. Or if you consider I there, you need to factorize. I talked about this, guys, the part of your factorization of these typical quadratic expressions. So the first thing, can you factorize that? -3 as 5x minus 3. Is it less than? 0 is greater than 0. I'm just going to have this one as our last question. All right, that's less than 0 there. This one, it is less than 0. This is what you're given. So you can tell on this one that the coefficient of x squared, as you can see, that's a 2 positive. So meaning to say we're going to have a smiley shape, which is fine. But we need the critical values, guys. The critical values from what? The factorization. That is where the factorization here plays a role. You have to factorize these. All right? Factorize this quadratic expression, this one. How do you factorize this type? All right. Using the different techniques or methods that we have been taught in class, you can apply those techniques on how to factorize such type of quadratic expressions. But I also explained different methods and also techniques. So make sure that you do go through those methods so that you do understand how to factorize. I'm just going to explain the cheat method for the sake of time, but use any other method that you do understand, guys. 2x squared minus 5x minus 3 like this. How do you factorize using the cheat method? We see that we are used to a factorization where the coefficient of x squared is a 1. But this time it is not 1, it is a 2. So we are going to apply it to the last term. So we take the 2, multiply it to the last term. All right, so this is what you're going to have. I explained this method, so make sure you go through the factorization of solving quadratic equations using factorization method for your grade 11. I explained that. So this is what you're going to have at the end. X squared minus 5x. It is a 2. Then on this side is going to be a -6. You multiply, that's -3 times 2, which will be -6. So at this stage, I said you will factorize as usual your quadratic expression that you have formed here, because the coefficient of x squared this time is a 1. So you're going to have x here and you're going to have x here. Focusing on the constant, remember how you factorize here, guys. This one you're used to factors of -6, which will give you a -5. The products, those are the one that you want. Comparing, you're comparing -6. Which products, guys? Two numbers, you multiply them, they give you -6. But if you add those numbers, they must give you a -5. You must be comparing of a -6 and a 1. A -6 and a 1. You can have 6 and a -1, a -3 and a 2, a 3 and a -2. All these, they are factors of -6, but we need only one pair. Each pair, one pair. When you add, you must get a -5 here. We add, you must get a -5. -6 plus 1, that's a -5. So we've got -6 and a +1. So what are we going to do at the end? We bring back the 2 that we multiplied at the end. Remember, we removed it. Now we bring it back on each part where there is x on our final solution. We must have the 2 here multiplied wherever x is. So we are going to multiply wherever x is. You multiply by 2 here, you multiply by 2 here. Then in brackets, wherever you see is possible, factorize. Do you see anything common? All right, the first bracket 2 is common. So you can factor that 2x divided by 2, that is going to be x, minus 6 divided by 2, that is going to be minus 3, into what? Into 2x plus 1. Whatever that you factored out is no longer useful. So remove that. So meaning to say our solution, guys, was going to be like this. In terms of factorization, I'm not saying solution of the inequality. I'm saying the solution, like the brackets after factorizing. You're going to have x minus 3. All right. That's x minus 3 here. Another one, it was going to be 2. This is the factorization part, guys. I'm not going to explain much about this factorization because there are too many ways of factorizing. It is you and your method that you understand is like this. Then you can determine your critical values from there. So what will be your critical values? Minus 3 to the other side will give us a positive 3. So x is equal to positive 3, or x is equal to what? The 2x plus 1 getting to the other side is going to give us what? That's a 0 there. So 2x is equal to minus 1 divided by 2 by 2. So x will be a minus half. So x will be a minus half. So this is it, guys. You factorized, which is fine. You are there. Your critical values are there. We now need the exact solutions according to the function that we're given. Already we saw that here. Our function, the part of ax squared plus bx plus c, this one, when it is compared to 0. This is already how it is given on our question. This is the ax squared plus bx plus c, guys. This is exactly what we are given on our question. So our comparison is that we saw that a is 2, so you're going to have a smiley shape like that. So let's have our smiley shape and then conclude. So let's just say we're going to something like this. All right, so comparing these values, the negative, so we're going to have our negative half on the left side. Then the positive 3 on the other side. This is your positive 3 on the right side. So using this, we saw that this is less than 0. When it is less than 0, we talked about this type of a shape. When it is less than this x-axis, so this is where we're going to have our solution. X must be greater than a, but less than b. So x is greater than minus half. X is bigger than minus half, but less than what? But less than 3. These are values in between. So guys, in your understanding of the simplifications of solving of these inequalities, it needs a lot of time. As we can see from these questions, it needs a lot of time that you have to work out as many questions as you can. Try to figure out, try to work out as many questions. The first thing, have the format. Okay, have the format. Because all these questions you see, you look onto the question like, okay, this is a complicated situation. No, it is not that way. Look into the question, formulate the normal quadratic expression that you are used, ax squared plus bx plus c. Compared to 0, is it less than 0? Is it? You must have something of this nature. That is where you talk of the factorization after that. If it is possible for you to have that factorization. Some questions, factorization is not possible. You cannot have a difference of 2 squares like question n here. How? It's not possible. We cannot factorize that. We cannot factorize x squared plus 4. It's impossible. So there we do not have solution. None. None. Other parts can be factorized. So do yourself a favor. Work out as many questions as possible. I'm going to end with one last question where solutions can also be none, or not to say none, but a condition where our solutions can actually be a complicated situation. Our solutions, look at this condition of part, if we check P, all right, if you check from this P, we must be very careful there. Q, R, S. Those questions, you must be very careful. Okay, let me just explain these ones because these ones, I think they're just direct, but do the rest, guys. So on P, this is x plus 4 squared. X plus 4 squared means what? There are two brackets. There is x plus 4 like this, another one x plus 4 like this. Then they're saying it's greater than 0. X plus 4 squared is x plus 4, x plus 4. But the solution is, when it comes to the critical values, are we going to have two critical values there? The first bracket, x will be equal to what? X will be equal to minus 4. The second bracket, x will be equal to what? X will be equal to minus 4. This was just one solution. This is just one solution. So what type of a function is it that has got one solution? All right, you multiply, remember the part of our function, we're going to multiply x and x. X times x is going to give us what? X squared. So meaning to say, if it is x squared, we're going to have what? Smiley shape like this. But it is not going to be like this because solutions cannot be minus 4 and minus 4 like this. It's impossible. So how is it going to be like? Because we cannot have 2 minus 4 on the same graph. There is only 1 minus 4 on our Cartesian plane in terms of x. There is only 1 minus 4. So meaning to say this is the type of function which is a solution at minus 4, and that minus 4 is also a turning point. Remember, it's supposed to be a smiley shape like this. The minus 4 is a solution, and it's also a turning point when it is like this. So this is how it is going to be like. So this is how our function was going to be like. Remember, this is your x-axis where y is equal to what? 0. So they are saying the whole function of this x, whatever that we have, is greater than 0. The whole part of our ax squared plus bx plus c is greater than 0. So where do we find our solutions? Above the x-axis. So if it is above the x-axis, we're talking about this side of the x-axis and this side of the x-axis. Above x-axis. That is where we want to have our solution there. So comparing now, because there are two. This side of the x, because there are two solutions that we need to have, but they're compared from one value. It is not two values that we have like previously, like this. There's a minus 4 here, and there's a 4, where we say it's above. So we need x is this. They are compared from one value, but there are two solutions compared from one value of minus 4. So therefore, we are saying our x, this side of the inequality must be what? Less than a 4. Remember, I said, guys, this side is less than, so that's less than a minus. This value is minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7. Compared to minus 4, what are they? They are bigger than. They are greater than minus 4, these x values. So that is how it is going to be like. So if you take a closer look, it is because we are given a condition where it is greater than 0. It is greater than 0. It is greater than a 0. All right, so this is our P. All right, so I'm saying P is fine. If we move on to Q, we're going to take the same thing. A Q, this is our Q here. So let us I'm just going to change. There it's Q. So on Q, this is what they are saying, guys. On Q, they are saying the same x plus 4 squared is greater than or equal. Now it is greater than or equal to 0. So this part was not going to change. You find your critical values as it is. They will be at minus 4. So being greater than or equal to 0, we have this way, guys. Like I said, on this side, what are these solutions? On this side, we are now saying on our solutions, x is less than or equal to minus 4, or x is greater than or equal to minus 4, according to this one. What just changed? It was a greater than. This one is greater than or equal to, guys. This is the only part that changed. So the solutions are only going to have the greater than, I mean the equal to. The equal to must be there on your answer. So this is the only part that is affecting P and Q. On R and S, let's be careful on those two. All right. So let me rewrite R and S here. All right, but for P and Q, you can relate those two also R and S. Let's start with R then. R, we are given x plus 4 squared is less than or equal to 0. This time they are saying it's less than. Take note. Your critical values, we're going to have the same condition. X plus, these are two brackets, x plus 4 less or equal to 0. So our critical values will be at x is equal to 4 to that side, will be at -4, or x is equal to a -4. One value that we're talking about, just like the previous case. But in this case, guys, if we were to have our solutions compared with our graphical method concept, this is what you're going to have, because we still have the coefficient of x squared as a positive. This one, when you multiply x and x, you're going to have what? X squared. If you multiply those two, we still have a smiley shape like this one. According to the previous case, we were having two solutions differently presented, A and B. And when it is less than 0, or it is less than or equal to, we're focusing solutions below the x-axis, which are in between A and B. But on this type of function, guys, our solutions, they are below the x-axis, which is A, because we do not have a region that is below the x that E and B. Where are we -4 here at this point on the x-axis, and it goes back with nothing. There's nothing there. There's nothing at all. So what can we say about our x? At the end, there is no solution in terms of the inequality to say x can be greater than this or x can be less than. We do not have that. We are just going to say our x will be equal to a -4, because we have a condition where x is what? Less than or the equal to this one is the one that is making us to say x can be equal to -4, because we are now taking it as an equation, the equation part. But in terms of the solutions of the inequality, there is no solution, guys. Be very careful there. There is no solution there. There's no solution there. There's no solution at all. There's no solution at all. All right. In a previous case, we could have, okay, let me explain this one on this other case. Remember here we said we can explain it as x is less than or equal to -4, or x is greater than or equal to -4. Guys, meaning to say values that are less than or equal to -4, or values that are greater than or equal to -4. It's like this. This is minus these ones. -5, -6, -7. Which values are greater than -4? We are talking of all real numbers. So on Q, we can give a special solution to say all real. Okay, all real values can be part of your solution. That is on that Q, we can also put it that way. But on this R that I'm explaining, there we cannot have all real values. The only value that we can put there will be at -4. Will be at -4. There is no other solution that we can take, guys, when it is like that. We are only taking this -4 because of our question. There was an equal to on our question. So the -4 cannot be neglected. We write as an equation. But if you check on S, we do not have solution at all, because it will be like this. On S, it is the same thing. X plus 4 squared is less than 0. As you can see, it is the same thing as this one. So you're going to have your critical values just the same way as we had when it is less than or equal to 0. You have your critical values, X graphical presentation. You draw your graph like this. This is at -4. But where are we going to have this? There's no solution. There we cannot say X, it can be -4. No, because of what? -4 is a critical value. There they're saying it must, there's a less than sign. There we took it because of the equal to sign. Otherwise, there was no solution. There was no solution at all. So in this case, there's none. We do not have a solution that is going to affect our answer in that case. So on part of S, we can say there is none. Do not have a solution there. You must be very careful. Your presentation, the questions that you are given. So I want you to try as many questions from this activity or from this exercise There are so many questions, and let's talk about those questions in the comment section. Around basics to obtain the critical values. Then from there, we are now talking of the solution of the inequality, which is compared with a zero there, which is compared in this manner. Where this, and we have got the last condition that we had, where we had to compare because it was a single solution, guys. There we have to compare because it's just a solution at -4. It's just one solution that we are having there at a single point. So this one you must compare with what is happening on your graph. When it is above the x-axis, it's fine because we can have our solution, but there is an equal to on the question. If the question has an equal to, then you can just say, okay, x is equal to -4. So these are your questions, guys. Please do revise as many questions as you can as you are preparing yourselves for the exams that are ahead of time. So like I said, we are going to need another method, but because of time, guys, we're going to have that one in another class or as another video where I'm going to explain another method which is using the number line to compare your solution. It's on the comparing of the solutions. The rest, finding critical values, everything is the same, only on the comparing of the solutions. So let's meet in another class, then we prepare for the exams, doing as many question papers as we can.